Okay, so domain and range is something you're going to be using for a lot of future math classes, so it's important to have a good foundation. So domain we defined as a list of all possible inputs of a function. I guess we'll just say just inputs, doesn't necessarily have to be a function. Okay, and our range is going to be a list of all possible outputs. And remember, our inputs are going to be our X values, while our outputs are going to be our Y values. So let's take a look at some examples here. So for this one, we get f of x equals 6 over x minus 3. Okay, so we start thinking about what are values that we can plug in for x. Okay. So for example, right, I could plug in the number 2 as an input. I get 6 divided by 2 minus 3, which is 6 over -1, which is -6. Okay, I get an output. That's great. So I know 2 is an input. Okay, so the number 2 is part of that domain. It's not the only number, but we know it's part of it. Okay, so we start thinking about what other numbers could potentially be it. Let's say I wanted to plug in 0 as an input. So I get 6 divided by 0 minus 3, or 6 divided by -3, which then gives me an output of -2. Okay, so 0 is part of the domain. Okay, -2, 2 and 0 are part of the domain. -6 and -2 are part of the range. Okay, each equation is going to be different. So let's say I plugged in 3. If I plug in 3, I get 6 divided by 3 minus 3, which then gives me 6 divided by 0, which is undefined. Okay, so I do not get an output. So what that means is 3 is not a part of the domain. And it gets difficult. I mean, if you think about it, after a while, you'll be able to recognize just based off the equation what's going to be a part of the domain and not. Okay, if we made a list or if we plugged in every single possible number, we would never get that done. So they just go on forever. Okay, so the different types of functions are going to dictate what our domain and range is. Can anybody think of another number that you could plug in that's not going to give us an answer or not going to give us an output? If I plugged in 5 million, is that going to give us an output? Yeah. Okay, 3 is going to be the only number that doesn't, because we can't divide by 0, right? And the only way to make our denominator 0 would be to plug in the number 3. Okay, so 3 is the only number that's not going to be part of our domain. So we would state the domain as all real numbers except 3. Okay, and that's one way to write it. There's a couple different ways to write the domain and range. We're going to keep it simple. Okay, a symbol you might see is basically an R with a line through it in the middle. That stands for all real numbers. Okay, just a little side note in there. Okay, so for the most part, we're going to be taking a look at graphs when determining the domain and range. Okay, so I'll show you a couple different examples. Okay, if you don't have graph paper, it's going to make it a little difficult. Okay, but let's just try our best here. That's the first one here. To determine our domain, okay, the easiest way to do it is we want to find what is our furthest input to the left, and then what is our furthest output to the right. Okay, and I like to do these little dotted lines, okay, because it makes it a little bit easier for me. So my furthest value to the left is going to be at this point here where my X value is -1, -2, -3, -4, -5. So for domain, and I'm just going to write a D, so I don't have to write out domain every time. But my furthest value to the left is going to be -5. And that's going to go to my furthest point to the right, which in this case is this one, where my X value is +2. So domain's always going to go from left to right, okay, whatever that furthest value is. Okay, range is going to be very similar, but instead of going left to right, okay, range deals with the outputs. So we are looking at what is our lowest value and what is our highest value. Okay, so again, I'm going to kind of use dash, dotted lines, whatever. Okay, just because for me personally, it helps me organize it a little bit better. Okay, range is going to go from your bottom number to the top number. okay, or the lowest to the highest. Okay, so my lowest output is right here, which is at negative 1, 2, 3, 4. My highest output is here at positive 1, 2, 3, 4. So range goes from negative 4 to positive 4. Okay, and we're including every number in between there, not just whole numbers, since it's a continuous graph. Okay, every point in between counts as an output. Left to right and bottom to top. Okay, no, so now looking at the second one, notice it's a little bit different. Okay, it is not a continuous graph. They are just points. Okay, so since we have points, when being asked the domain, we're being asked what are all the possible inputs. Okay, and since I have 5 points here, I'm going to list out each one of those points. So in this case, my input value for this one is -2. I have an input of 0, of 1, of 2, and 3. And I want to list them out because I'm not including all of the points in between them. I don't have an input of -1 because there's no point there. However, if I drew a connection between all 5 of these points, and a line was connecting them, okay, then -1 would be an input because it'd be a part of that line. Since there's no line, there's no connection, okay, -1's not an input. Range is going to be the same way. Okay, we're only listing outputs. So I have an output here of -3, an output here of -1, 0, 1, and 2. So it's important just to identify the two differences of when the lines are connected and when they're not. So again, on this one, if I wanted to say, do I have an input of -1? I do. It's right here. Okay, I don't know what the output is. It's going to be, a decimal of sorts. All right, but I know it exists because the line's right there. Here, I don't have an input of -1 because there's no dot. There's no point. So I wouldn't want to say from -2 to 3 because -1's not included in that. Two more examples here. So on this first one here, notice we have arrows, meaning the graph continues going in that direction. Same thing with this one. Okay, So when we are trying to identify the domain, trying to identify what is my furthest value to the left, I understand the graph keeps going to the left. Okay, with that arrow, it just keeps going and going. So my furthest value to the left is going to be negative infinity. All right, it just keeps going to the left forever and ever. And it also goes to the right forever and ever. Even though it's going down at a faster rate, it still continues going to the right. So my domain is from negative infinity to positive infinity. Okay, that's a scenario where we could also use the all real number symbol. Because all real numbers can be included in our domain. Our range, our lowest value goes down forever and ever. So we go from, once again, to negative infinity, raises back up forever and ever, positive infinity. You'll occasionally see it written as all real numbers as well. Okay, so notice all these things over here on the bottom left-hand side, negative infinity to positive infinity, this symbol and the phrase all real numbers, okay, they all mean the same thing. So if you're ever asked what is domain and range and you're being given a cubic function like this, should be easy points because it's just going to be negative infinity to infinity, all real numbers. All right, last example. Okay, again, I'm going to make my little marks just to help me organize a little bit more. Domain for this value to the left is right here. 1, 2, 3, 4. So it goes from -4 to 1, 2, 3, 4 to +4. Okay, my furthest value to the left, -4, furthest value to the right, +4. My range, lowest value here, 1, 2, 3, is from -3 to 1, 2, 3 to +3.